Okay, welcome back. And now what we're going to do is we're going to fit a logarithm. We're going to fit a logarithmic function to the data. Okay, so we're going to do the exact same thing. We've done this before. Let's do it again. Okay, so this is what we're going to use. We're going to use the ln reg on our calculator. So we're going to use the natural logarithm function, regression function on our calculator. So I'm going to show you the so I'm going to show you the data, and I stuck it in my calculator already. So I'm going to show you the data, and this data has to deal with sales of a video game. And, oh, hold on a second. Wrong one. Not that one. This one is dealing with, oh, where is it? Oh, here. This is life expectancy. So this is in the of Americans from 1900 to 2010. So 1900 to 2010. Okay, so I'm going to show it to you here. Okay, so there's the data. So from 1900 to 2010 gives you the life expectancy in years. And that's in 10-year increments. Okay, so every decade. Okay, so what I did was I entered that in my calculator. So time is the independent variable, so always is. So year is the x variable, and life expectancy is the dependent variable. So what I did was I entered it into the calculator, so I went to stat edit, and so there it is in my calculator. Okay, so I entered it in there. Double check your data. Always double check to make sure you didn't make a typo or anything like that. So now I'm going to go to the scatter plot, second y equals, and again it's on. Make sure your scatter plot is on, and you check the for the scatter plot the graph type here. And now I'm just going to go to zoom, and I'm going to go to number 9 for stat plot, or zoom stat I mean. And so this is what it looks like. Okay, so it does look sort of like a logistic model. It's not perfect, as you can see, but real data is rarely ever nice and smooth. Okay, so now what we're going to do is we're going to fit a logistic model and see how it fits. So we're going to use the calculator to find the best fit model. So now I'm going to go to stat, I'm going to go to calc, and now I'm going to scroll down until I find the ln reg. Okay, and there it is. So now I'm going to hit enter, and now I'm going to again choose my L1, my list 1, my list 2, separated by commas, and then I'm going to use my y1, right? My y variable, because I'm going to store my equation in the calculator. So I'm going to do L1, comma, L2, comma, now I'm going to go to vars, and I'm going to go over to y vars, and I'm going to hit enter for functions, and I'm going to hit enter for y1, and so now this is what I have on my calculator, the home screen. Now I'm just going to hit enter. Oh, wait a minute, what happened? What happened? Oh! Hold on, I didn't clear my y equals. Oh, that shouldn't matter though. Oh, let me see. Let me try it anyway. So now I'm going to hit enter. No, still. Domain. Oh, my domain. So I got a domain error. So now what I'm going to do is I'm going to go back to my lists because something might have happened. So let me go back to my list. You know what? I think it's because of the 0. Because I put 1900 as 0. Okay, okay. So now they did in the textbook, now just so you know, in the textbook they put 1900 as x equals 1, and then they put in 1910 as x equals 2, and so on. I was actually going to go number of years. I was defining x as number of years since 1900 to make it more applicable, but that's not going to work in this case. So you know what I'm going to do? I'm just going to use the 1900s. By the way, it's not going to change. It's going to change the numbers than what's in the textbook, but it won't change the way the shape of the graph looks or the using the function, using the model. So I'm just going to quickly put the actual years in here. 1900, 1910, 1920, 1930, 1940, 1950, 1960, 1970, 1980, 1990, 2000, 2000, 2010. Okay, so I'm going to double check. Okay, now I'm going to zoom. Okay, so now there's my graph. So it didn't change anything. All it changed was the scale, so it didn't change the shape at all. So now what I'm going to do is I'm going to go to Stat, and I'm going to now go to Calc, and I'm going to go to Lin Reg, and now I'm going to put in my information again. Okay, so there we go. Now I'm back to this. Now I'm going to hit enter, and that's what I get. Now my numbers are going to be different than the ones in the book, but you'll see that I get the exact same answer for the next part. Okay, so here's what my function looks like, my regression function. It's going to be f of x equals, again, the calculator gives me y equals a plus b ln of x. So my function is going to be negative 4249.636 plus 569.446 times the natural log of x. That's my function. Okay, now that's part B. Now, let's see. Oh, now what they want us to do is, they want us to predict, okay? They want us to predict what is going to be the expected life, what is going to be the predicted life expectancy for an American in 2030. Now, this is extrapolation because we're predicting into the future. We're outside of the data, so this is called extrapolation. So now, we're going to just plug in, 2030 here, right? Or, guess what? Now, what I'm going to do is I'm going to plot this. So now watch, I'm going to go to Zoom, Stat Plot, and now look. Hold on one second. There we go. Yep, that's right. Okay, so it's not perfect, right? I mean, it almost looks like a straight line, but that is the regression analysis. Okay, now I'm going to go to second calc, and now I'm going to hit value. So I'm going to choose value, and now I'm going to put in 2030 and hit enter. Oh, wait a minute. Oh, my window. I have to change my window because it's 2030 is not on the window. So let me quit window, and I want my X maximum to be 2035. And let me make my Y maximum 95. Okay, so now there's my graph. I had to play around with the window. Sorry about that. In this case, because I'm extrapolating, I have to open my window further this way. So I just extended it up and down, up and over a little bit. So now I'm going to do the same thing. So I'm going to do second calc value. Now I'm going to plug in 2030. Okay, right like that. Now I'm going to hit enter. Now look at that. So based on this model, the predicted expected life for Americans in 2030 is going to be approximately 87.14 years. Okay, so almost 90. By the way, if you look at the statistics on life expectancy, if you take out car accidents and things like that, so things that those sorts of things like from skydiving, automobile accidents, stuff like that, actually our life expectancy actually is more of than 95 or higher, okay, which is fascinating to me. Okay, so but anyway, that's how you do it. Have a great day.